So what we do is we combine this relationship table with this department entity table, because here you can see what is the maximum cardinality of department, that is 1. What is the maximum cardinality of department? That is 1, right? And because it is having the maximum cardinality as 1, or you can say it is having the key constraint, this is the reason why we can combine both of them. And when we are going to combine them, the main reason of combining them is because we want to have as minimum duplicate values as possible. That means we want to reduce the redundant values, or you can say redundant records from the table. So even if we combine both of them, still we are not going to have a lot of redundant values because of this key constraint. Okay, because of this, because the maximum cardinality of department is 1. Okay, and the maximum cardinality of employee is m, so that is many. So the relation is called as one to many here in this case. Okay, so now let us take a few examples. Here in this example I've created some relations, and the top I wanted to ask you, if you are going to convert these relations into this complete AR diagram into a relationship, then how many tables you are going to require? So take the first example. In this example, if you are going to convert this as a table or relation, then you are going to require the first table for this. You are going to require one table for this, or you can say one relation. You are going to require one relation for this, or you can say one table. And for this relationship you are going to require one table. But here you can see it is having the key constraint. Right, because the maximum cardinality of B is 1. That is why you can combine this table for this relation and the table for B. So you can combine these two tables. So in minimum you are going to require 2 tables only. One table is for this and second table is for this. We are going to require 2 tables only. Okay, so the attributes in these 2 tables will be like this. In the table A, the attributes will be A1 and A2, where A1 is a primary key, or you can say A1 is a key attribute. In the table B, we are going to have the attribute as B1 and B2, and we are going to have the attribute as A1, and this A1 will be acting as a foreign key which is pointing to this A1. Okay, so we are going to have these 2 tables. Now if you check the next relation, it is a many to one relationship, and here you can see there's a key constraint here. It is the same thing. We are drawing the above table above one like this only. I'm not showing any attributes. So here you can clearly see that we are going to require only 2 tables to convert this AR diagram into a relationship. Now in the next table you can see it is many to many, because here it is many cardinality, here it is a many, or you can say cardinality is more than 1, maximum cardinality is more than 1 in both the sides. In both the sides we are not having any key constraints. For this purposes, because of A, we have to create a table for A, table for this entity A, we have to create a table for this entity B, and we have to create a table for this relation R. So there are at least 3 tables required, because there are no key constraint. But here in the next diagram you can see that there is a key constraint in both the sides. That means the maximum cardinality is 1 in both the sides, or you can say it is a 1-to-1 relationship. Now in this 1-to-1 relationship we are going to require 2 tables. Number 1, the first table, either you can combine A and R. So first table can be combined, you can make the first table by combining A and R, and second table can be B, or you can do something like this. The first table is only A and second table will be combining B and R. So we are going to require only 2 tables to convert the following relational ER diagram to the relation. Okay, now let us take more examples after this. Let us take these examples. Let us see how can you convert, how many tables are, number of tables are required to convert these ER diagrams. So take the first diagram. Here you can see that it is a one-to-many relationship because we are having a key constraint here, and we have already done this kind of example. So we already know that for this example we require 2 tables only. And what are those tables? In the first table we are going to combine, we are going to have A, and because there's a key constraint at this side, so you can make it A1, A2, we are going to have this one, and because there's a key constraint at this side, so we are going to have, okay, so I did a small mistake here, let me correct it out. I did a small mistake, sorry guys. Fine, so here it should not be like this, it should be like this, because both the examples will be same. Sorry, it should not be like this. Right, now it is representing a one-to-many relationship. Okay, one-to-many, because here you can see the maximum cardinality for B is 1 and the maximum cardinality of A is M. So you generally write it like this. So it is one-to-many ER diagram, or you can say one-to-many relationship. Here you can see we are going to require two tables, and the tables will be like this. The first table, generally what happens is we make three tables. One table is for A, one table is for B, but one table is for relation R. But because it is a one-to-many relationship, therefore for this one-to-many relationship we require only two tables. All this information can be stored only with two tables. The tables can be like this. The first table will be A, which will be containing A1 and A2, where A1 is a key attribute, and the second table will be for B and R, for this combining B and R. So it will be having B1, B2 and A1, where A1 is a foreign key, and this B1 is a prime attribute. You can say it is a key attribute here. Now if you check the second diagram, in the second diagram you can see it is a many to one relationship. There's a difference between above one and this one, so just the difference will be there in while combining the relation and the entity. So you can make AR as first table, and it is having the attribute A1, A2 and B1, where B1 is acting as a foreign key and A1 is acting as a key attribute. And the same way we are going to have the second table, which is containing B1 and B2, and B1 is a key attribute, right? So this is you can convert this AR diagram into a relation. If you check out the third diagram, you can see we are having two A1, A and B. These are two entities, and this is a many to many relationship, right? It is a many to many relationship, and cardinality, maximum cardinality of A is many, and maximum cardinality of B is also many. So you can see for this A, we can create a table that is A1 and A2. And for this B, we can create a table that is B1 and B2. In the table A1 is the it is the key attribute, and in the B1 is the key attribute. Okay, and then for this relation, because it's a many to many relationship, we have to create a table for this relation, and we'll be having A1 and B1, A1 and B1 as the key attributes. That is, these are the foreign key to their respective relations, right? So if we have a many to many relation like this, then we can use this. Okay, now check out the next diagram. Here they are saying this is having one-to-one relationship in both the directions. So if you have a one-to-one relationship, then in this case we are only going to require two tables. We don't require more than two tables. And for these two tables, either you can combine this A with the relation R, so you can make a table AR, which is having the attribute A1, A2 and B1, and the second will be the table B, which is having B1 and B2. This is one way of creating the table. Or the second way of creating the table is, instead of combining A and R, you can combine the next table, that is B and R. So you can also make a table like this, A, which is having A1 and A2, and you can make the second table as BR, which is having B1, B2 and A1. So where A1 is a foreign key, so here B1 was the foreign key and B1 is there as a key attribute. Okay, so this is how you can combine this one. Now if see, you generally get a lot of questions related to this in your examination, so I'm going to take some previous year questions also, and I'm going to try to convert them. Okay, so let us see. If we have a relationship set with a key constraint and the participation constraint, the only thing which is differentiating here is the participation constraint. That means here you can see in the diagram that department is having total participation. Department is having total participation. When do we have a total participation? When the minimum cardinality for a relation is greater than 0 or it is 1. So we have already seen this in the previous video. If you face any problem with the terminologies in this video, you can go through the previous videos, and they will really help you out. Okay, so you can see here each department is required to have exactly one employee as a manager, right? So if this is the requirement, so you can see if there is a key constraint, merge the relationship set table with an entity set table. If the entity set table is totally participating with the relationship set table, then foreign key with not null constraint. We are going to use a foreign key with not null constraint. If you check this out, let us see what we have done. If you have a total participation here, then you can see for employee we can create a table for employee like this only, but for the total participating side we are going to create this department ID, we are going to create the department name, and because it is a total participating side, therefore we have to include a foreign key from this. Okay, see guys, there's a difference between if I am writing a relationship like this, it is manages, and it is like this. There's a difference between this, and if I show a relationship like this, there's a difference between this. Okay, and what is the difference is, you can see from this side this entity is having the maximum cardinality as M, and this entity is having the maximum cardinality as 1, right? They are not discussing about the minimum cardinality, or you can say participation is the minimum cardinality. Okay, here not discussing about the minimum cardinality, but here when I'm saying it is total participation, that means the minimum cardinality or participation is 1. Okay, that is why this is like this only. Okay.